Okay, let's go to the next section. Here we will talk about some of the values that stated in the property table, how they are calculated. Well, we actually depend on the reference state and we can get the reference value. Because what are important to us is the change of those values instead of the actual value. So we need to give a reference point to set that to 0, and then we can guess the value. So here, we set that the values of U, H, and S, okay, the S is the rightmost columns, okay, we will talk about this in chapter 7. The values of U, H, and S are calculated from some measurable properties using the relations between them, okay, but those relations are based on the changes, okay. Well, for the details of the relations, please go to McCann 3300. Okay, the first part of this course talk about how the property table are constructed by using so-called relations inside these two sentences. However, the relation just talk about the changes. So we need to give so-called reference state. We need to select a state to be a reference state and set the value of 0 for the calculation. It's just like what you see in elementary mechanics. If you need to talk about the GPE, because we just have the value of the change, so we need to set a point to be the reference point and guess the relative gravitational potential energy about that point. Okay, it's just the same thing. And here in our table, the reference state of water will be 0.01 degrees C, and we set all of the properties there to be 0. And for R134A, it will be negative 40 degrees C in the tables. Okay, and remember that those reference values in the table are just some values that we arbitrarily selected and conventionally selected. They have no significance in the thermodynamic calculations, okay? Because as I mentioned in chapter 2, even for the energy content, the changes instead of actual values are more important, okay? Here, this is the table for the older edition of the book, okay? So you will see that the layout has been a little bit different, but the numbers are pretty much the same. And you will see that for the temperature table at 0.01 degrees C, the saturated liquid, the UF is equal to 0.000 because we have set this one to be the reference state. Similar to the enthalpy, we also have exactly 0 here, but for the enthalpy it's a bit different, okay? For the saturated refrigerant 134A, we have used negative 40 degrees C as a reference point. So here you will see that the enthalpy is 0 and the entropy is also essentially 0. But you may ask, why these two are different? Why these two are different? Okay, as I've mentioned, this enthalpy is equal to U plus PV, and this PV must be positive. So there will be some kind of difference. So we just take either one of them to be 0. Okay, either one of them to be 0. For the water case, we have the internal energy equal to 0. But for the R134A, we have the enthalpy to be 0. Okay? And the next example, we would have a so-called summary of what we have learned in section 3.4.